and switch to the full screen. Alright, hi guys, welcome back to Intro to iOS Development. Today we're going to have a guest lecture on persistence and SnapKit. I won't spoil what persistence means, but it'll be really useful in your hack challenge projects. So first, some logistics. The drop deadline is November 20th, which is coming soon. If you guys were in danger of failing, which mostly no one was, you would have received an email from us already. So if you haven't received an email for us, don't worry about that. And secondly, the hack challenge is currently going on. If you guys are not currently on a team, as in you didn't submit a team formation form with someone else, please make a private post on Piazza as soon as possible so we can get you guys on a team, because participating in the hack challenge is mandatory and it is a huge portion of your grade. Alright.
Okay, is it on?
Yeah.
Alright, so hello everybody, I'm Yan Lum and I am an Android developer on Cornell App Dev. I did iOS last semester, so today I will be giving a lecture on persistence and SnapKit. So first off, with persistence, what is persistence? Persistence is basically being able to store data locally on your device, and how we achieve this is through user defaults, codable core data, CloudKit, and UI document. But for this lecture, we will be focusing on user defaults and codable. So when do we use user defaults? It's to achieve lightweight persistence and also store small amounts of data, such as user preferences. And some examples for user preferences is on Slack, where there's light or dark mode, and these things can be easily stored for each individual device using user defaults. And in this sense, you won't have to create a backend with login functionality to differentiate between different users. And user defaults also tells how an app should behave at startup, hence the word defaults. And so what can we store with user defaults? Data is stored for as long as the app is installed. So if you open an app, you manipulate data where user defaults is updated, and then you close the app and double click on the home button and swipe up or whatever to completely close the app, and then you reopen the app, that data will persist. But if you do uninstall the app, then the data will no longer be there. So user defaults can store basic data types like booleans, floats, doubles, ints, and strings, or more complex data types like data, date, arrays, and dictionaries. So for this lecture, we will be focusing more on the data complex types, so for custom classes. So some user default examples with AppDev's iOS apps are Ithaca Transit and Eatery. So with Ithaca Transit, we can favorite routes, where if you close Ithaca Transit, you can see that the routes stay favorited and show up above. And with eateries, you can filter what eateries you want to look at, and if you close eatery and reopen eatery, then the filters will remain what filters you set the previous time you opened the app. So using user defaults, we're going to talk about setting up user defaults and default values, storing data, retrieving data, and using custom classes. So with setting up user defaults, it's pretty simple. What you do is you instantiate this user default standard object, and then you register a dictionary, which is kind of similar to JSON or a Python dictionary or a Java hash map, in that you map a string key to whatever value that you want to be associated with that key. So in creating this dictionary, you can later get the data out of user defaults by referring to this key. So storing data in user defaults, here's an example with strings and an example with ints. So basically you just say user defaults dot set Yan Lum for key name, because Yan Lum's my name, and then later you can go into user defaults and get the string Yan Lum back using the key name. And it's like the same thing for ints, where you can say user defaults dot set 18, which is my age, for key age. So then retrieving data from user defaults, here's like an example of strings again. We use like an if-let statement because like user defaults is a dictionary. So sometimes if you try to get a value from a dictionary using a key that's not already defined within a dictionary, we'll get like a nil value. So we say if let name equals user defaults dot string for key name to unwrap this like potential, well, to unwrap this optional value. And so because we set like the key name to be associated with the value Yanlum from the previous slide, we will get Yanlum as name. And then similar with ints, if we let age equals to user defaults dot integer for key age, we will get 18. So here we have like dot string and dot integer, which like refer to like the primitive types that we know that the value will be. But there's also like a generic user defaults dot value for key that we can also use, and that just returns a data type in like any. And what we want to use is string and integer if we know for certain that value is a certain type. Otherwise, if we have any and we want to like manipulate or update the data, we will have to do some typecasting or like type checking. So using custom classes with user defaults, we have to conform the class to codable and NS object, which will allow you to decode and encode your custom class into like a data object to be put into user defaults. So this is also pretty simple. You can just say, okay, user defaults dot register like the string song array as like the key referring to your array of data kind of types. So you can encode from like your custom class like a song array to like a data array by saying let encoder equal to JSON encoder, and then if let encoder object encoded object equals to try encoder dot encode songs, then user defaults dot set encoded object for key song array. So in this example, like encoder dot encode songs, we see here that songs is the song array, and what the encoder is doing is it's turning that song array into a data array object, which then can be set into user defaults associated to like the key song array. And then similarly for decoding from data to like a song array, we say let decoder equals to JSON decoder, and if let stored songs equals to user defaults dot data for key song array, which will get the data object out of user defaults, and then we say songs equals to try decoder dot decode the song array.self, which is like, that's like the class that we're trying to decode this data array object into, and then from stored songs is like what the actual data array is. So we're going to start with our demo. So hopefully you guys have downloaded the starter code from Piazza. It's under resources if you haven't. Okay.
You can ask everyone if they're ready.
Is everyone ready? Or not ready? Well, I'm gonna go. As you can see, we're just, if you click play, this is pretty much the same as like your assignment 4, which is like the music playlist, where there's like a table view with different songs. You can click on a song, which brings you to this detail view to like update like the information if you want to. Like, I guess what's different is like the favoriting option of like you can like click on these hearts to favorite the songs, but because like we haven't like added like the user defaults persistence yet. Well, I can't close that. That's too bad. We'll try to use the iPhone XR, I guess. Alright, so what should happen is like if you try to close the app completely and swipe up and then reopen the app, then you will see that the songs don't remain favorited, which could lead to like a bad user experience because when you favorite a song, like you would expect the song to stay favorite when you open the app again. Alright, so here we have the iPhone XR, so you see that you favorite the top one, and you swipe this away, and you reopen the app, and then the song is no longer favorited. So we're going to use user defaults and persistence to keep like the songs favorited or unfavorited. So just like looking around the files, we see like view controller, it's like pretty much the same as P4. What we are going to be changing are like this function for create songs, where we're going to have to retrieve the songs, like the favorited songs array from user defaults and like check which songs have been favorited and update those songs accordingly. And we will also be looking at this favorite button tapped function where we will be updating the user default state array and then like, yeah, just like manipulating that array for like what songs have been favorited or unfavorited. So then for the detail view controller, it's pretty much the same as P4. So later in the lecture, we're going to go through these constraints and kind of like change them from like just regular NS layout constraints to SnapKit. So then for the playlist cell, pretty much also like the same as P4, but like with this is favorite boolean and this is favorite button, which we will look at to make sure that we are updating this like is favorite within user defaults. So then for the song class, we have name, artist, album, image name, and is favorite. So notice that image name is a string, and we can't have like, let's say image equals UI image, or let's just keep it as that, because if we save it, it will no longer conform to decodable and encodable, which is why for now we will just keep it as a string. And because we will be like matching like the songs within like the user defaults to like the songs that we have, I'm just going to quickly add a var ID in here just so like you can like match the songs easily. So self.id equals ID. So this way, like I'm just going to play it so that like I get the errors of where I have to update the ID. So within create songs in the view controller, we can just set ID equals 0, ID equals 1, and etc. And this is like a common practice in backend to have an ID if we know for certain like different kind of objects are like need like a unique identifier. Alright, so then that should compile. Okay. So we're going to start off, as I said before in the presentation, by creating the user default standard object. So what we say is let user defaults equals to user defaults dot standard. And then now that we have the user default object, we can register it, register, and create the dictionary where we have a favorites string mapped to a data array. And what's important to note here is that the key favorites needs to be exact all the time when you are trying to get this data array and update it, which is why we are going to actually create a new file Swift file called strings. And this is like also good for like creating global variables. Like for instance, you'll probably have a bunch of like different colors in like your hack challenge projects that will be reused in different files. So in that case, you can make like an extension of UI color and use those colors elsewhere. But for this, we will have static var favorites equals to favorites. And that just creates like a global variable that you can use in different files and make sure that you're using like this exact favorite string and you aren't like mistyping or anything. So then back in app delegate, we can replace this favorite string with strings.favorites. And then we will instantiate our JSON decoder and encoder by saying let encoder equals to JSON encoder and let decoder equals to JSON decoder. And this just allows you to use like encoder and decoder to change your song array into a data array and vice versa when we go to our view controller. Let's see. So first off, we're going to update like what's actually favorited or unfavorited. So within favorite button tapped, when it's tapped, we're going to say if let stored favorites equals to user defaults dot data for key strings dot favorites. This will get the data array from user defaults, which is like corresponding to the key favorites, and call that stored favorites, and then we will have to decode this favorites data array into like an actual song array. So we say var favorites equals to try decoder dot decode, and then the type that we want to change this data array into is a song array. So we say song.self from stored favorites. And then once we have this array, we want to update the favorites, and because we are clicking on like an empty heart and we want to favorite a song, we will say favorites dot append song. And then now that favorites array has been updated, we have to update this in user defaults. So we say if let encoded favorites equals to try encoder dot encode favorites. Then we will set the new favorites array into user defaults by saying user defaults dot set encoded favorites for key strings dot favorites, and this will update the user defaults with the yes.
In the line where you're decoding and you say song.self,
Uh-huh.
that's giving it the class type,
Yeah.
right? But is it like making a type for an array of songs specifically?
Well, yeah, because like we want because like stored favorites, it's like an array of songs, but like as like data objects.
So did we define a type that's an array of songs, or does it just like infer that there's a type for that?
Well, like we define like the song type itself, but then like have like this is like it's like the same with like an array, like to instantiate it or like to give it a type, then you just like have like the square brackets with like inside. So like this here, like the if let statement, this only executes if like user defaults can get the data array from the strings.favorites key, but like sometimes like if you haven't already instantiated like the key within user defaults, then you'll get back nil, and in that case you can say else and then have let favorites equals to just like the song and then like pretty much do the same thing as above. So if the encoded favorites, he goes to try, and then once again it's just like changing that song array into the data array and putting it back into user defaults. So then for unfavoriting a song, we have if let stored favorites equals to try or user defaults dot data for key strings dot favorites to once again get like the data array from user defaults, and then we also want to change this. We also want to like decode this and change this into the song array. So we can just take that from there, and so we are going to update this favorites array, remove like the song, and then encode it and put it back into user defaults. So what we're going to do is do favorites dot remove all where song. The song ID equals, well actually I'm going to use S because we have the variable song up here. So if that song ID equals SID, it's going to be removed from the array, and then we can encode the favorites and then put it back into user defaults. Okay. So then after that, we like manipulated the data within user defaults, but we're actually not using it anywhere. So we're going to go up to create songs, where we're going to retrieve data from user defaults and kind of like update these songs to have is favorite to true if they're in the user defaults array. All right, so then for that, we will be using if let stored favorites equals to user defaults dot data for key strings dot favorites, and then variable favorites equals to try decoder dot decode song dot self from stored favorites, and then we're going to loop through the songs array, and if favorites dot contains, we're going to use like a contains where and pass in each song within the array from user defaults by using the $0 ID, and then match it to the song's ID. And if that occurs and the song is a favorited song, then we just say song.isFavorite equals to true. So then if we run this, and alright, so unfavorite those, we can just favorite those three. Alright, swipe that away, and then reopen the app. We see that the data for like the favorites persist and the songs are favorited. So if you look in song.swift, there's actually uncommented code for like to change the image name into like a UI image instead of string. This is actually uploaded in last semester's lecture on our YouTube channel that you guys can look at if you want to know more about doing persistence. But for this lecture, we will be moving on to SnapKit. So what and why should we use SnapKit? SnapKit allows for more flexibility with constraints, and it allows for chaining which results in shorter and cleaner code. So back to our demo. Right now, if you look at the view controller and you look at the constraints, we see that like a lot of these are similar in that the playlist table views left anchor matches with like the views left anchor, and it's like the same thing with like the table views right anchor, the views right anchor, and then like the bottom anchor. So instead of like doing all these different times, we can import SnapKit. And then just comment this out and say playlist table view dot snap dot make constraints make in make dot left dot right dot bottom dot equal to view. So this is just saying to make the left, right, and bottom anchors all equal to the views left, right, and bottom anchors. And because the top anchor, like for the view.save area layout guide, and the view, their left, right, and bottom anchors are pretty much the same, we can actually add top into this statement and say view.save area layout guide instead. And if we play this, you see that we pretty much get the same constraints. So what if we have like more complicated constraints? So we're going to go into our detail view controller and just like go through these constraints and update them accordingly. So again, if you import SnapKit, and we can just take out song label for now. Let's see. Here we again we can like use view.save area layout guide for both like the left and top anchor, and because like the constant is both 18 for both of them, we can just like shorten them into one line of code. So song label dot snap dot make constraints make in make dot left dot top dot equal to view.save area layout guide, and then to have like the constant offset, we can just say dot offset 18, and then for the rest we can do make dot width dot equal to 60 and make dot height dot equal to 20. And notice here that like instead of having to have equal to and equal to constant for referring to like a constraint or like a constant, we can just use equal to for both constraints and constants. So then we will be doing the same with artist label, where we can say artist label dot snap dot make constraints make in, and what we see here is that the left, width, and height anchors are all the same as song label, so we can just say make dot left dot width dot height dot equal to song label. But then for the top anchor, it actually matches to the song label's bottom anchor. So for that, we do make dot top dot equal to song label dot snap dot bottom, and that allows you to refer to like the bottom anchor or like a different anchor from like a different view. And then we have the dot offset is 24. And then for album label, we see that it's pretty much the same. It refers to song label for left, width, and height. So we can just take this and update that, and then we see that it's looking at the artist label's bottom anchor for its top anchor. And then, so for the song text field, it's pretty different in that like all 4 of its cases, like there's no way to condense that. In that case, you would have to separate it. So make dot left dot equal to song label dot snap dot right dot offset by 10, and then make dot right dot equal to view, and then dot offset of -18, and then make dot height dot equal to 30, and then make dot center y dot equal to song label. Oh yeah, and I forgot to mention this, but like the also great thing about SnapKit is that you no longer have to have these translates auto resizing mask into constraints equals false if you are one of those people who forget those often. So we can just delete that. And we continue with making artist text field dot snap dot make constraints make, and then we see, okay, so the left anchor corresponds to the song text field left anchor, and then the right anchor to the right anchor height to height. So then all we have to make sure is that the center y is different, so we say make dot left dot right dot height dot equal to the song text field, and then make dot center y dot equal to artist label center y. And then album text field is pretty much the same, so we can just copy and paste this and change this to album text field, and then make sure that we have the center y corresponding to the album label. And for here, song image view, we can say song image view dot snap dot make constraints make in make dot center x dot equal to view. And notice here that the width and the height have like the same constant and are the same, so we can just say make dot size dot equal to 300, and then for the top anchor we can set that to the album text field dot snap dot bottom dot offset 100. And so right now, you click into this, this is how the constraints look like. And if we play this, right, we see that the constraints are the same. So SnapKit just allows you to shorten and clean up your code. And like one more thing that's pretty cool about SnapKit is like, let's say you thought like, okay, these cells are just way too close to the edge and you wanted to create an inset. You can easily do that by saying dot inset and then create a UI edge insets and like say, okay, I want like a 20 padding all around my table view, and if we play this, then we'll see that like an entire like 20 padding is around our table view. So that pretty much wraps up my lecture. Oh yeah, do you guys have any questions? No?
Does anyone need to see any code again?
Can you go back to the padding for a second?
Yes. Okay.
Alright, can you go back to the keynote?
Oh.
Alright, so just some final action items. We no longer have any more like weekly projects, but you guys still do have your hack challenge project to work on. Your mentor should be contacting you through email or should have already contacted you to set up your midpoint checks. So these will just be like short 30-ish minute meetings with your mentors, so you'll get both a backend mentor and an iOS mentor. Ideally, you should try to schedule like your meeting so everyone can be there, but if it needs to be, you can kind of separate iOS and backend because you'll have one mentor from each for each class, basically. But for the iOS requirements, those are linked in a document on the Hack Challenge Piazza, so make sure you're in that as well because all the like information about Hack Challenge is going to be there instead of our own iOS Piazza. So once you meet with your mentor, they'll go over and like make sure you have all the requirements you need for your midpoint submission, and those will be due on CMS on this Friday at 11:59 p.m. As long as you meet with your mentor and you like get an all good from them, you should have no problems with your midpoint submission grade. And then finally, we won't be having lecture the coming Monday, which I believe is the 26th, because a lot of people will be gone for Thanksgiving break. But we will have lecture the Monday following that, so December 2nd, I think. Yeah, that's all.